So hello guys, welcome back to alGOds. We are back with another exciting problem, that is to find the longest increasing subsequence in an array. So we have a few approaches to solve this problem. The first is simple brute force approach, that is to consider every possible subsequence and then determine the longest increasing subsequence. So we know that if the length of the array is n, then there are 2 raised to the power n possible subsequences. So this approach is not recommended so much due to its exponential time complexity. So there's another approach that uses dynamic programming and it solves this problem in a complexity of big O of n square. But today we're going to discuss another interesting way to solve this problem. Now this method solves this problem in a better time complexity, that is big O of n log n. So let's get started. So we are given an array and we'll find the longest increasing subsequence for this array. Now let us begin with an empty subsequence and we'll append numbers to the subsequence as and when required. So the first number that is under consideration is 10. So to this empty subsequence we append the number 10, and till this point the longest increasing subsequence is 10 itself. Now the next number that is under consideration is 4. Now there are two possible subsequences here, that is 4 alone and 10 alone. We cannot have 10 and 4 as a subsequence because this is not an increasing subsequence. So this cannot be a valid candidate. So now we have two subsequences, both of length 1. Now we can see that we can discard this subsequence that consists of 10, because let's take a look at the situation. Now suppose after 10 and 4 there are two elements 6 and 11. So if we consider 10 alone, uh, at this point, we are at this point right now. So if we consider 10 alone, the longest subsequence that we can arrive at would be 10, 11. So the length of this subsequence is 2. But on the other hand, if we consider 4 as the subsequence, then the longest subsequence that we can arrive at is 4, 6, 11. And the length of this subsequence is 3, and we would definitely want to choose this subsequence because we want to arrive at the longest subsequence. So basically why we can discard 10 is because any subsequence 10 can 10 can take us to, 4 can take us to as well. So and 4 can indeed even do better in some cases, as in the case we just discussed. So if there are two subsequences of the same length, then we can easily discard the subsequence which has larger elements, because the subsequence with smaller elements can do better. So in this case we discard the element 10. So right now we have a subsequence that is 4, and yeah, we have the empty subsequence as well. So the next number that comes into consideration is 6. So at this point we have the empty subsequence, we have the subsequence 4, and we can also have this subsequence 4, 6, because this is also an increasing subsequence. So now this subsequence has a length of 2 and this subsequence has a length of 1. But we cannot simply discard this subsequence because it is of a smaller length at this point. So let us look at this situation as well. Now let us suppose the numbers are 4, 6, 5, 6 and 7. Let's suppose this is the array and we are at this point right now. If we consider the subsequence 4, 6 to be our candidate, then the best we can arrive at is 4, 6, 7, which is a subsequence of length 3. But if we consider 4 as the subsequence, the best subsequence we can arrive at is 4, 5, 6, 7, which is definitely a better choice. So we cannot discard this subsequence 4 just because it is shorter at this point. It might it might be a better answer at some point in the future. And this definitely does not mean that we'll discard this longer subsequence, because what if there were no elements after 4 and 6? What if the array was simply 4 and 6? In that case, this would be the longest subsequence, so we cannot discard this as well. So we'll consider both these subsequences. Now let's move on to the next number. The next number that enters is 3. So yeah, before that, another important thing. Now we will have an array. We will keep track of all the elements that are present in the end of the subsequences. That is, at we already we've already arrived at a position that at any given time there will only be one subsequence of a particular length, because we saw how we can discard 10 from this set of subsequences. So at a given time there will only be one subsequence of a particular length. So at this point there are two subsequences, one of length 1 and one of length 2, and we'll keep track of the last element of these subsequences. So 4 is the last element of the subsequence of length 1, and 6 is the last element of the subsequence of length 2. Now when we just have a look why we require this array, or why we require these last elements. Now the next element that enters is 3, and we see that we cannot add 3 to this subsequence, we cannot append 3 to this subsequence as well, because they would not be increasing. And so 3 can be appended only to this empty subsequence. So we append 3 to this empty subsequence, so a new subsequence of length 1 arise in the set. So we can discard this subsequence of 4, because we already decided that we'll keep the smaller elements only. So once this subsequence has entered the set of subsequences, we know that now the last element of the subsequence of length 1 is no longer 4, but it is 3. So we update this, and the set of subsequences now is 3, 4, 6, and the null subsequence. So this is a set of subsequences right now. So now let's move on to the next element, that is 9. So now we can observe here that we add an element to the longest such subsequence which has its last element smaller than the element that arrives. So we added 3 here because the null subsequence was the longest subsequence which has a last element smaller than 3. So in this case 9 can be added to this subsequence 4, 6, because it is the longest subsequence which has its last element smaller than 9. So we can append 9 to this subsequence, and we already discussed that we cannot discard 4, 6 from the scene just because it is smaller right now. So after 9 has been added, 9 has been encountered, this is the set of subsequences, and we can see that there is a subsequence of length 3 and the last element of this subsequence is 9. So we can update this array as well, and let me just write it properly. So this is the array as of now, and this is a set. Now the next element that arrives is 5. Now we have to find the longest such subsequence which has the last element smaller than 5, and clearly that is 3. That such a subsequence is 3. So we append 5 to this subsequence, so it becomes 3, 5, and we see that there are two subsequences of length 2. We discard the subsequence which has larger elements. So now we have to update the last element of the subsequence of length 2, and we change it from 6 to 5. because the set has been updated. So right now the set is the null subsequence 3, 3, 5, 4, 6 and 9. So this is the set and this is the array. So now we have seen that we insert 5. So first of all we can notice that these elements in the interior or the interior of the sets of the subsequences do not really matter. The only thing that matters while inserting a new element is the last elements, and these last elements are sorted in this order, and we can see that from this array as well. So basically whenever we insert a new element, we are inserting it at a position at the longest subsequence which has its last element smaller than it. So the last element should be smaller than the element to be inserted. So basically in this tail array which is sorted, we are inserting it we are inserting a new element at its correct position. So if there is because see at this point we are inserting a 5, and the 5 the initially the array was 369, and when we are inserting 5 at this position, the array would remain sorted 359. So we are basically finding the point at which we can insert a new element and then updating this array. So let's look at another example. It will get clearer as we solve this problem. So the next element that enters is 2, and we need to find the position at which 2 can be inserted in this array such that this array remains sorted. So 2 has to be inserted at the first position so that this array is sorted, and we see that there is 3 in that position, so we simply replace this 3 by 2. And what this means is that we are appending 2 to this empty subsequence, and because there are 2 subsequences of length 1, we discard the subsequence which has larger element. So eventually this updation is valid because the last element of the subsequence of length 1 is 2. So this is correct. Now let's move ahead. First of all, let me make this array here, length and last element. So the array is 2, 5 and 9 right now. So the next element that comes into the picture is an 8, and we see that an 8 can be inserted at the third position such that the array is sorted. So there is a 9 there, so we replace this 9 by an 8. Now this does not mean that this subsequence 469 has become 468. We are not replacing this 9, but we are appending an 8 to the previous subsequence such that it becomes 358, and then discarding this subsequence because it has larger elements. So the set now becomes a null subsequence 2, 3, 5, 8. Okay, there's a 3, 5 here, 3, 5 and 3, 5, 8. So this is the set. So it does not mean that this 9 is being replaced, but the entire subsequence is being replaced. Now let us update the list here as well. Instead of this 9, there is an 8 now. So the next element that is under consideration is a 3. So a 3 comes into the picture, and the point of insertion for this 3 would be at the second index because the array is 2, 5, 8, and a 3 can be inserted at the second position. So we change this 5 to 3, and we can change this 5 to 3 as well. So what this means is that a 3 is being appended to this subsequence, and then this subsequence is being discarded. So the set now becomes 2, 2, 3, 3, 5, 8, and there is a null subsequence as usual. So the next element that comes into the picture is a 12, and the insertion point of 12 is at the last position because it is the largest element. So we need to insert another element in this array, that is a subsequence of length 4, and the last element would be 12. So we can easily verify this because a 12 will be appended to this last subsequence to make it 3, 5, 8 and 12. So now there is a subsequence of length 4 which has the last element 12. So now let me just rewrite this so that it becomes a little bit cleaner. Oh, sorry, this is a 3. So yeah, so we have our set which looks something like this, and the next element that enters is 5, and we can clearly see that the insertion point for 5 would be at the third position. So this 8 would be replaced by a 5, and this 8 would also be replaced by a 5. And what this means is that this subsequence is appended with a 5, and then we replace this subsequence because it has larger elements. So our set looks something like this: 2, 3, 5, 3, 5, 8, 12. And the next element is 7. So the insertion point for 7 would be somewhere here. So this 7 would be at the fourth position. So we should replace this 12 by 7, and in the set what happens is that this subsequence gets appended by a 7, so it becomes 2, 3, 5, 7, and this subsequence of length 4 gets discarded. So our set has been updated, and so should be our array. So now the next element that is present in the array is 3, and the insertion point of 3 is the second position, but there is already a 3, so we can consider this 3 being replaced by another 3. And what is exactly happening in the set is that a 3 is being appended to this subsequence 2, and now there are two subsequences that are same, so we simply discard any one subsequence, so the set remains the same, and so does the array. So the last element that is present in the array is 11. So the insertion point for 11 would be at the last position because it is the largest element. So we add another element to this array. So now there is a subsequence of length 5, the last element of which is 11. So what is happening here is we add one element to this subsequence which has 4 elements. So it now becomes 2, 3, 5, 7 and 11. So this is our array, and this subsequence is the longest subsequence because it has a length of 5. Now let me just write the set one more time. It has a null subsequence. It has 2, 2, 3, 2, 3, 5, 2, 3, 5, 7, 2, 3, 5, 7, 11, and this is the longest increasing subsequence. And there is one important thing that we need to note here is that this array, although it is the same as this subsequence, this cannot be treated as the longest increasing subsequence because it is what it denotes is simply the last element of every subsequence in this set. It does not denote, it is not the longest increasing subsequence. In this case, by chance, the both the longest increasing subsequence and this array are similar, but it does not mean that it will be the case always. Now let's look at this example. Suppose there was a 0 after this 11. The last element of this array is a 0. So what would happen is the insertion point for 0 would be at the first position. So this 2 would be replaced by a 0, and what is happening here is the null subsequence is being appended with a 0 and we are discarding this 2. So the longest increasing subsequence is still 2, 3, 5, 7, 11, but our array has been changed to 0, 3, 5, 7, 11. So this definitely is not the longest increasing subsequence in this array, because 0 is the last element and there are no elements after 0, but in this array there are elements after 0. So this does not give the longest increasing subsequence. That is something we need to keep in mind. So this was how we solved the longest increasing subsequence problem. The length is given by the size of this array, and the longest increasing subsequence is this. So we simply needed to find the length, and that we have done. So now let's quickly look at what the complexity of our algorithm is. As I already told you, it is order of n log n. Let's see how. Now when we are inserting elements into this sorted list, we can make use of something called a binary search. We know how a binary search works, and it works in log n time, and there are n elements that are need to be considered. So the complexity is simply n log n. I hope you understood this solution, and see you again with another video. Thank you for watching this video.